So in this section, we're going to use the quotient rule for differentiation. So suppose we have two functions, differentiable functions, f of x and g of x. So when we have it in the quotient form, f of x over g of x, then the differentiation is given by the quotient rule. So let's do one problem, and that will help us understand how this rule is used. So here we have the rational function 2x plus 3 divided by x squared minus 5. So let us begin differentiating the given function. So we start with the denominator, which is g of x. So we square it. So we have x squared minus 5 whole squared. Then in the numerator, we begin with the denominator itself, g of x. So we have x squared minus 5. So that will be multiplied to the derivative of the numerator, which is 2x plus 3. Now here we have a minus. Now the order is extremely important, so we have to follow in this particular fashion. Then we have the numerator, which is 2x plus 3, and that will be multiplied to the derivative of x squared minus 5. So that is equals to x squared minus 5 multiplied to, so we have derivative of twice of x. So 2 being a constant, we can take it out of the derivative. So that gives us 2 times the derivative of x plus the derivative of 3 minus 2x plus 3 times the derivative of x squared minus the derivative of 5 whole divided by x squared minus 5 whole squared. So we have x squared minus 5 multiplied to 2 times the derivative of x, which is 1, so that gives us 2, plus the derivative of the constant function 3 is going to give us 0, minus 2x plus 3 multiplied to the derivative of x squared, which is 2x, minus the derivative of, that's 0, whole divided by x squared minus 5 whole squared. So we have finally 2 times multiplied to x squared minus 5, so that will be 2x squared minus 10, and we have positive 2x multiplied to 2x plus 3, so that gives us 2x times 2x will be negative 4x squared, and negative 2x times 3 will be negative 6x, whole divided by x squared minus 5 whole squared. So 2x squared minus 4x squared is going to give us negative 2x squared minus 6x minus 10 divided by x squared minus 5 whole squared. So this is the derivative of the given function with respect to x. So let us do another problem. So we have the rational function x plus 3 divided by x squared plus 1. So we'll use the quotient rule to find the derivative of this given function. So we begin with the denominator, which is x squared plus 1. We square it and write it in the denominator. Then we again begin with the same denominator, x squared plus 1, in the numerator, and then multiply it to the derivative of the numerator, which is x plus 3, minus x plus 3 times the derivative of x squared plus 1. So that will be equals to x squared plus 1 multiplied to the derivative of x plus derivative of 3 minus x plus 3 times the derivative of x squared plus the derivative of 1 whole divided by x squared plus 1 whole squared. So we have x squared plus 1 times derivative of x is 1 and derivative of 3 is 0 minus x plus 3 multiplied to derivative of x squared is twice of x and derivative of 1 is 0 whole divided by x squared plus 1 squared. So we have x squared plus 1 minus, so twice x multiplied to x will be 2x squared and 2x multiplied to 3 will be 6x, but that will give us negative 6x divided by x squared plus 1 whole squared. So we can combine x squared, so that is going to give us negative x squared minus 6x plus 1 whole divided by x squared plus 1 whole squared. So this is the derivative of the given rational function. Let's do another problem. So we have x squared plus 1 divided by x plus 1. So we need to find its derivative with respect to x. So let's begin with the denominator. So we have x plus 1 whole squared in the denominator. We begin with the denominator x plus 1 and then multiply it to the derivative of the numerator, which is x squared plus 1 minus x squared plus 1 multiplied to the derivative of x plus 1, which will be equals to x plus 1 times the derivative of x squared, which is twice of x, and the derivative of 1 is 0, so I've skipped it, minus x squared plus 1 times derivative of x plus derivative of 1, so derivative of x is going to give us 1 whole divided by x plus 1 whole squared. So we have 2x multiplied to x, so that will be twice x squared, plus 1 times 2x will be twice x, minus x squared minus 1 divided by x plus 1 whole squared, which is equals to x squared plus twice x minus 1 divided by x plus 1 whole squared. So this is the derivative of the given function with respect to x. Let us do another problem. So here we have the rational function 2x minus 1 divided by x squared plus 1. So we need to find its derivative with respect to x. So we begin with the denominator. So we have x squared plus 1 whole squared. So in the numerator we start with the denominator x squared plus 1 times the derivative of the numerator 2x minus 1 minus 2x minus 1 multiplied to the derivative of the x squared plus 1, which will be equals to x squared plus 1 times the derivative of 2x, so 2 being a constant, we can pull it out of the derivative, so we have 2 times the derivative of x minus the derivative of 1 minus 2x minus 1 times derivative of x squared plus derivative of 1 whole divided by x squared plus 1 whole squared. So that will be equals to x squared plus 1 times 2 times the derivative of x as 2 minus the derivative of 1, which is 0, minus 2x minus 1 times the derivative of x squared is 2x plus derivative of 1 is 0, then divided by x squared plus 1 whole squared. So we have 2 multiplied to x squared plus 1, so that's going to give us 2x squared plus 2 minus 2x is multiplied to 2x, so we have negative 4x squared. So negative 2x multiplied to negative 1 will give us positive 2x whole divided by x squared plus 1 whole squared. So we finally get 2x squared minus 4x squared, so that will be negative 2x squared plus 2x plus 2 whole divided by x squared plus 1 whole squared. So this is going to be the derivative of the given function with respect to x. Let us do another problem. So here we have the function x plus e raised to the power of x whole divided by 1 plus log of x. So we have to find its derivative using the quotient rule. So we begin with the denominator. So we have 1 plus log x, so we take the denominator and square it. Then in the numerator, we begin with the function in the denominator, which is 1 plus log of x, and then multiply it to the derivative of the numerator, which is x plus the exponential function, minus the numerator, which is x plus e raised to the power of x, times the derivative of the denominator, which is 1 plus log of x, whole divided by 1 plus log of x multiplied to the derivative of x plus the derivative of the exponential function, minus x plus e raised to the power of x times derivative of 1 plus derivative of the logarithmic function, whole divided by 1 plus log of x whole squared, which will be equals to 1 plus log of x multiplied to the derivative of x, which is 1, plus derivative of the exponential function, which is the function itself, minus x plus e raised to the power of x. So derivative of 1 is going to be 0, and we have derivative of the logarithmic function, which is 1 over x, whole divided by 1 plus log of x whole squared. Now we can multiply the numerator and the denominator by x. So we have x multiplied to 1 plus log of x times 1 plus e raised to the power of x. So x multiplied to 1 over x is going to give us 1. So that leaves us with x minus e raised to the power of x whole divided by 1 plus log of x whole squared. So this is the derivative of the given function with respect to x. So let's move on to the next question. Oh, before that, there's a mistake that I made. So since we have multiplied x to the numerator, so we need to multiply it to the denominator as well. So this is the derivative. Let's go to the next question. So here we have the rational function 1 divided by ax squared plus bx plus c. So we have to find its derivative with respect to x. So let us begin with the denominator. So we have ax squared plus bx plus c whole squared. Then in the numerator, we start with the denominator ax squared plus bx plus c multiplied to the derivative of numerator, which is 1, minus 1 times the derivative of the new denominator, which is ax squared plus bx plus c. That will be equals to ax squared plus bx plus c. Now we have the derivative of the constant 1, so that will be 0, minus 1 times the derivative of ax squared, so a is a constant, so we have pulled it out of the derivative. We have a times the derivative of x squared plus b times derivative of x plus derivative of the constant coefficient c, whole divided by ax squared plus bx plus c whole squared. So we have ax squared plus bx plus c times 0 will be 0, so we have negative a times the derivative of x squared, which will be 2x, plus b times the derivative of x will be 1, plus the derivative of the constant coefficient is 0, all divided by ax squared plus bx plus c whole squared. So we finally get negative 2ax plus b divided by ax squared plus bx plus c whole squared. So this is the derivative of the given function with respect to x. Let's do another problem. So here we have the function e raised to the power of x divided by 1 plus x squared. So let's find the derivative using the quotient rule. So we begin with the new denominator, the function, which is 1 plus x squared, and then we square it. Then in the numerator we have 1 plus x squared, which multiplied to the derivative of the numerator minus the numerator times the derivative of the denominator, which will be equals to 1 plus x squared multiplied to derivative of the exponential function will give us the function itself minus e raised to the power of x times, so we have derivative of 1, which will be 0, plus derivative of x squared, so that will be twice x, whole divided by 1 plus x squared whole squared. Now we're going to take e raised to the power of x as the common function. So we have 1 plus x squared minus 2x in the numerator divided by 1 plus x squared whole squared. Now 1 plus x squared minus 2x is this expansion of the identity a plus b whole squared, which is equals to a squared plus b squared plus twice of ab. So here if we consider a to be equals to 1 and a to be equals to x and b to be equals to negative 1, so we have x minus 1 whole squared, so that gives us x squared plus 1 minus 2x. So our final derivative will be e raised to the power of x times x minus 1 whole squared divided by, so let's write it as x squared plus 1 whole squared. So this is going to be the derivative. So let us do another problem. So here we have the function 1 plus e raised to the power of x divided by 1 minus e raised to the power of x. So let's find the derivative using the quotient rule. So we have 1 minus e raised to the power of x whole squared in the denominator. Then we have 1 minus e raised to the power of x in the denominator multiplied to the derivative of the numerator, which is 1 plus e raised to the power of x minus 1 plus e raised to the power of x multiplied to the derivative of 1 minus e raised to the power of x, which will be equals to 1 minus e raised to the power of x times derivative of 1, which will be 0, plus the derivative of the exponential function is going to give us the function itself minus 1 plus e raised to the power of x times derivative of 1 is 0 minus derivative of e raised to the power of x, which is e raised to the power of x itself. So we have 1 minus e raised to the power of x whole squared. So we get 1 minus e raised to the power of x times e raised to the power of x plus 1 plus e raised to the power of x times e raised to the power of x whole divided by 1 minus e raised to the power of x whole squared. Now we take e raised to the power of x as the common factor. We have 1 minus e raised to the power of x plus 1 plus e raised to the power of x divided by 1 minus e raised to the power of x whole squared. So e raised to the power of x and negative e raised to the power of x cancels out. So we get 2 times e raised to the power of x divided by 1 minus e raised to the power of x whole squared. So this is the derivative of the given function with respect to x.